Hi, everyone. Good to see you again. It's been a long time. Thanks, everyone, for coming out for RPM Symposium this year. We're down to the Marines here, the few and the proud, but we appreciate you being here. Hope you found the last 2 days to be valuable and informational. Hope you're leaving with practical solutions that you can implement in the near future. And I hope that you like the new format this year with ending here. I want to welcome our closing keynote speakers, Mark Hatfield and Jason Spettel, who have a combined 75 years of experience working with industrial machines and industrial facilities. Mark Hatfield serves as HECO CEO. He has over 47 years of experience in the electric motor and equipment management industry. In his role, Mark leads HECO's strategic direction decision-making and is actively involved with business development. Mark has spearheaded many of HECO's strongest equipment management programs and partnerships dating back to the 1980s. He is the original thought leader from HECO on all things related to equipment management, equipment storage programs, and the philosophy and approach that HECO takes. As a second-generation owner of HECO, he spent his entire career at HECO and served in a variety of capacities, including being president for over 30 years. Mark has been actively involved in the Electrical Apparatus Service Association for many years, previously serving on the Technical Education Committee. Jason Spettel serves as the Director of Reliability and Senior Reliability Engineer for HECO's Predictive Service Group. He has over 25 years of experience implementing and managing predictive maintenance programs. In his role, he manages a team of professionals, including predictive maintenance technicians, who serve HECO's valued clients. His duties include scheduling, maintaining tech certifications, client service and communications, reviewing and overseeing contracts and technical reports, as well as overseeing the day-to-day operations of his group. Prior to joining HECO family in 2014, Jason served a variety of roles at Entergy at the Palisades nuclear plant, including predictive maintenance engineer, program engineer, and systems engineer. Before that, he served as a reliability engineer for Predictive Maintenance Services, Inc., a company owned by Jason's father that HECO acquired in 2013. Jason earned his bachelor's in science in mechanical engineering from Michigan State University. He's a certified reliability leader, ISO certified Category 3 vibration analyst, Level 1 thermal infrared thermographer, and ICML Level 2 machine lubricant analyst. Jason has been a member of the Vibration Institute since 1994. He currently serves as chair for the local chapter, a service role he's held for the past 4 years. Their presentation today is called, Are You and Your Assets Prepared? A Holistic Approach to Equipment Maintenance and Management. In this presentation, they will show you what it looks like when you connect preventive maintenance, predictive maintenance, equipment repair, and equipment management practices. When this is done, you're fully prepared for issues as they come up, and you avoid unplanned downtime as much as possible. It all starts with understanding what maintenance practices should be in place for each piece of equipment. Some assets are run to failure, and others include remote monitoring with a performance guarantee. Most assets are in the middle of those somewhere, and it starts with identifying what maintenance philosophies you should apply to that asset. From there, the presentation transitions into what do you do when there is an issue or anomaly. Do you have a spare? Is your spare ready to operate when needed? Is the spare previously repaired? By who? To what specification? When all of this is connected together, you're able to see what's going on with your equipment, get rid of issues as they arise, and prevent future issues from happening. Doing these things well will help to create peace of mind and confidence that your equipment will operate effectively, have longevity, and reduce total cost of ownership. Everyone, please welcome Mark Hatfield and Jason Spettel.
Well, it's pretty hard to follow that one now. Gosh, he's pumped me up so much. I think anything I do is going to be a letdown. But no, as Justin said, hopefully you've all enjoyed the last couple days. This presentation is kind of actually a culmination of something we've been working on over the last 7 years. Even talks yesterday kind of fed into this one, and Mark and I were actually talking yesterday that our keynote address yesterday by Mr. Fry, we didn't work on these together, but it's amazing the correlation that both of these come. So it's a good front, and we got the book in, and we'll get everybody out of here and make you all smarter. So kind of just before we get going, honestly, a couple of years ago, you started hearing the term holistic, maintenance, and it's kind of like, what the heck? I mean, you hear about holistic medicine, and it's kind of like, okay, what is that? So I honestly looked it up and said, what's holistic? And said, really, it's based off of holism. It's the idea of various systems should be viewed as a whole and not merely as, a collection of the parts. So when we started looking at it, it's like, everybody out there, some of you guys are really great at predicting problems coming up and are really ahead of things, and others are really great at when a problem arises that you guys can put that fire out really fast to take care of the problem, get the plant up and running. Our whole idea is saying, hey, let's merge all that together. Who can be really good at taking care of the problem when it happens? Problems are always going to happen. We can't take care of everything in advance. They're going to happen, but are you prepared for it? And then there's always, hey, now we're predicting, we are prepared, we can now schedule that time. So kind of the whole idea is we want you to get good at both. So kind of why is this all important? I mean, everybody's seen this nowadays. I kind of put on your supply chain issues. You can't find people. If you do have somebody, they're not trained. How long is it going to take to get them trained to actually do the job correctly? The big one, time and budgets. Who used to have 8 guys in their maintenance department, now you have 5. You're saying you got to do the same budget that you had before, now you have 5 guys, and you're expected to do everything that those 8 guys were doing? How are we going to take care of all this? Production levels are higher, and the failures hurt more. I mean, who hasn't had a plant yet that says, hey, we're going to increase production by 10%? We're going to increase the speed, another 50 RPM, 50 feet per minute than what we had before. Everything's about trying to get it out, but hey, you still have the same, well, actually have less budget and less people to take care of that. So, kind of extremes here, but why is it important? I mean, hey, if the time and budget, who hasn't heard about, levee issues down in, south? Money isn't allocated correctly. They're not doing the right PMs. They're not going out and checking on it. Do you want to have that failure? Do you want to have that dam that breaks? Anybody in Michigan ever hear about a dam breaking and causing some major issues? And what was it? Lack of money, lack of resources, lack of PMs. Yeah, these are extreme situations. So, what are we thinking about more with everybody here dealing with? Look what's around you. Everybody has motors and equipment. We're out there doing the inspections now because we want to find those small problems. They may be small, but they can be catastrophic to your plant. So it's trying to figure out what do we need to do to make sure we can catch all these problems before they happen. So again, why is this kind of important? By connecting our predictive maintenance, our preventive maintenance, and equipment repair and equipment management, this creates that holistic approach. Getting all these working together going to give you everything that you want to have in your plant. It honestly gives you a peace of mind and a better quality of life. So I know, probably most of you already know it, but I always like to start, make sure we go over it. Kind of just building on our bases here. There's really 3 main, maintenance philosophies that everybody's running in plants. You've got your breakdown maintenance or you run to failure. Like I said earlier, you're the firefighters. Hey, it's broken. Plant manager comes over and says, we got to go fix it. And you go take care of the problem now. You look like a hero. But, what was sacrificed to have that done? Then we get in our preventive maintenance. I cannot probably talk anywhere close to what Mr. Fry talked yesterday on it, but it's important. It's, mitigating your failures by, planning and changing out parts based on some, schedule. Doesn't mean it's always right, but it's something we're doing. And then really in the last 40 years is really where predictives come around. Predictive technologies have come around to be able to help us start to understand and utilize those technologies to say, hey, can we identify that problem coming and then get ahead of it and know about it beforehand? So this is one of the things. How do you correlate these? How do they really make sense to people? It's really the medical industry. And if you think about it, there's really this direct correlation between what we're doing out in plants and medical industry. Then honestly, this all came from my wife was kind of tired of trying to explain to all our relatives and friends and coworkers. I said, I'm a reliability engineer. And they're like, what does that mean? An hour later, I'm still talking to them. They still go, I still don't know what you mean. And she finally just one day said, hey, it's, he's an engineer. Still calls me that quite a bit, but it's down there. Someone who applies scientific knowledge to a problem and has a common tendency to overcomplicate a simple solution. Yeah, Alejandro, I see you're laughing. You spend enough time with me, so you know it's true. But finally, she started talking and said, one day she's like, oh my gosh, it just dawned on her. She's like, you're a doctor for rotating equipment. And at first I was like, what are you talking about? She's like, well, she heard me get the phone calls. Somebody says, hey, my machine's running hotter than usual. She's like, it's when our kid gets up in the morning, he's like, I don't feel good. And you go over, you put your hand on, and you're like, oh my gosh, you got a temperature. Something's wrong. Or hey, my machine's making a weird sound. Well, you're coughing, you have something. You're like, okay. I'm like, Okay, where are we going? She said, well, what do? You call the doctor. You schedule an appointment to go in. The doctor's going to run some kind of tests on you, come back and look at those symptoms and say, oh yeah, you've got bronchitis or you've got strep throat. She's like, well, isn't that kind of what you do? And I'm like, well, yeah, we come in and we look at it and say, yeah, it's running hot. We take some vibration readings and go, you know what? You've got a bad bearing. We've got friction inside there. It's causing heat, wow. So then she started saying, yeah, doctor for rotating equipment. I'm like, I like that. Sounds a lot better than engineered. And then we started digging into it a little more and saying, hey, you look at the medical industry, since medicine really has come around, I mean, the average life expectancy is 30 years longer now. And I said, man, if we can do that at our plants, what's that going to look like? How many people live with machines right now that you go, every 2 years this one's going to fail, and every 2 years we're just going to replace it? Why do you want to live with 2 years? What if I could say 7 years, 15 years, 20 years? I mean, think of what that could change for you. I mean, we all like living longer. You want to get to ripe age of 70 so you can actually retire nowadays and maybe enjoy life, for all those years. But, this, like I said, much of this increase is due to the ability to diagnose illnesses at the early stages and then change it. So why is that any different? It's the same thing we want to do. The medical field relies heavily on the use of diagnostic testing, being proactive. So if we can take that same proactive approach, bring that into our plants, shouldn't we see the same thing? Shouldn't we expect the same type of thing to happen to our plant machines? Increase that life. So again, just want to get down. We want to make sure we get all the bases first. So, we're going to just quickly go over, break down, maintenance or run to failure. And we mostly call it run to failure. I mean, it's, how do you take care of that? You're stocking parts, you're having spares. But some of the downside of this, highly unscheduled downtime. It's 2 o'clock in the afternoon on a Friday, and the plant supervisor comes by and taps you on the shoulder saying, hey, we've got something going on with line 17. We got to get out there and take care of it now. I'm not sure what broke yet, but it's down. We have to have this up and running. So unscheduled downtime. The guy who's getting ready to leave at 3 o'clock, you're tapping on the shoulder saying, hey, cancel your night plans. You got to come in and work. Again, it's difficult to plan. It's a lot of emergent time. It's costing a ton and doesn't work well for just in time. Now, I know I make this sound really bad, like, oh my gosh, we shouldn't have run to failure, but honestly, there's every plant has assets that are actually run to failure and actually fit by that, and we'll talk about that more. Quickly just looking at, again, Mr. Fry covered this really heavily, but our preventive maintenance, now we can schedule those activities. We can schedule our man hours a lot better, especially now that we're shorter on time. We can allocate and say, hey, we got 200 man hours this week to do work. What PMs are we going to do? Spare parts can be ordered, and it makes it a lot easier. But some of the disadvantages are, maintenance schedules are historically based. We talk about increasing speeds, and again, Mr. Fry talked about it. That's great. When did somebody come up with that idea? How many failures occurred? And you say, okay, that's going to be the frequency. It's going to be 2 years. Well, how often does that one asset every once in a while say, you know what, in a year and a half I'm going to fail instead, and you didn't have it. And then your boss is down your throat saying, why didn't we get this in time? Oh, go adjust the PMs. Now we're due PMs every 13 months. Well, what did you just do? That's more planned downtime, more parts. Again, I make this sound really bad, but again, when you look at it, every plant has equipment that should be done in preventive maintenance. And like I said, we're getting to our last one, predictive. That's using our route-based monitoring. That might be ultrasound, that might be thermography, vibration, PDMA, any of those technologies out there. But now we're starting to say, let's go out, and our maintenance is now based on the condition of the machine, what we're seeing right now. Looking at how it's trending, and it's just got a simple trend chart on the side from years ago on something where we had alert levels and fault levels based on historical information, saying now we can watch it, we can predict it and say, hey, we know we hit above 0.12 inches per second peak. That's where we want to go in and say we need to schedule doing our work. And then based on the time, you can extrapolate over and say on November or here, like a October, time frame, you need to shut down because if we go any higher, we're going to actually get up to the point where we're going to have a fault. We're going to start breaking stuff. So we want to take our actual what's going on in the equipment and say we're going to take it down. Nice part is downtime can be minimized. Spare part usage is you only get them when you need them, and overtime, can be minimized. Sounds great. And it has been great. It's a good change. Again, everything falls into it. And then really in the last 20 years, we've started having, in our predictive, we've had remote monitoring. That's really because the Internet of Things has really brought in a whole new level to be able to monitor our assets and figure out what's going on. Again, it's, IIoT based. And with this, it allows us to get to what we like to call a granular level of data. And we'll talk about it a little bit here on the side. Gives us a better chance to capture. We start talking about it. You can look at the example inside, and not really looking at the dollar amounts, but when we really get down, one of the systems looking at, you're gonna get 3 distinct readings every day. And we looked at this at a plant that was gonna have us come out and do weekly readings, on their critical assets. It said, if we look at that with the remote monitoring, we're gonna get 13,140 data points in a year. If we'd gone out and done route-based, walking out there once a week, we get 624. We're talking 21 times the amount of data. We can start seeing what's going on at a much earlier stage. And by that, we can make those decisions a lot earlier than even our frequency. And it's a lot better. You can actually allocate your resources better, letting the software programs go in and actually get the data, and then having your couple predictive guys actually can monitor a lot more equipment. We'll look at it here, just kind of a snapshot of it. You can see the other benefit is, the top is the trend chart. Same kind of trend chart we had before, but this is now looking over like a 3-month period, and we have multiple data points in a day. Notice anything strange on these? If I'm an analyst and I came out on July 11th, what did I get? Nothing. The asset was down that day. That was the day I was supposed to show up and take the readings. I got nothing. I have no idea what the machine is going to be like when it starts next time. If you look back into the June time frame, what we see there is we start seeing some peaks going up and down. Depending on if I showed up on June 5th, I would have seen one reading, but that's different than what I would have seen on June 12th. By having your remote monitoring, it allows us the chance to capture. How many people have reliability or vibration guys who want to show up at 2 o'clock in the morning to go out and do their rounds? I don't think many of you want to do that. I honestly don't want to do that. But I've had a number of phone calls that say at 2 o'clock in the morning, the pump started vibrating really bad. We show up at 7 o'clock in the morning and the pump is smooth. Okay, what was wrong? I don't know, I can't tell you anything. What I have right now is that snapshot in time. So by getting that remote monitoring, we're actually able to get to that granular level, see what's happening, see what maybe plant and process changes are going on. Are they good or are they bad? So, kind of get into it, and again, this chart should seem very familiar. I think we all saw it yesterday. I just took it now and put it at the standpoint of saying kind of where do the 3 maintenance practices kind of fall on the chart. And obviously you can see on the one side, so we get down, corrective action, that's our breakdown, our run to failure. That's where we're gonna be. That's usually when you find somebody in the plant, an operator, put his hand on an asset and went, whoa, that's smoking hot, that's, glove, we gotta change this out. We're already to a point that there's a failure happening. Our preventative maintenance, that's moving everything back, but again, doesn't mean we're gonna catch everything. But we're moving in, we're just changing parts out, and now we have a little bit more control over it. And then moving back in our predictive, that definitely allows us to get a better idea and look for it. And everything before the top part is getting to that design and installation phase. And actually, we're going to talk a little bit more on that, as we kind of go through this presentation. And then just on the bottom, I think, Mr. Fry had the same thing, is repair costs. Repair costs go up the farther over on the curve you go. Hey, everybody has unlimited budgets right now, right? You can walk to your plant manager and anytime you need it. Actually, it's kind of funny, when you are broke down, there kind of becomes an unlimited budget. Checkbook is open there, get the plant running, but when it's running and you want to bring in new technology, that checkbook's like, nah, maybe not. This is just another one, just kind of looking at it. Again, I'm gonna preface, just because you see predictive and I see the optimum point and you see in predictive, I'm not saying predictive is the best thing in the world and forget everything else. This is just saying you need to look at all of them. There's gonna be some assets that corrective maintenance is good for. It's low on cost. There's gonna be some assets that preventative maintenance is better to do, and then you're gonna find it. The whole idea is you've gotta look at your equipment and find where's that optimum point. Look at your plant, find the optimum point. Bring in all 3 maintenance practices and say, where can I save the cost? Is it worth all the expenses for all the technology, have all these trained guys, or do I have to have more mechanics, or do I have to have more parts? Try to optimize where we're at. So now this is, if you walk out of here, this is one of the top things I cannot emphasize enough. Asset criticality. That's the building block for everything we do, everything you should be doing. If you understand the criticality, you're already going to be on a path going forward that's going to be a lot better. If you don't, and I'll challenge that, a lot of people probably don't understand it completely. We look at this plot, we use this on everything we go forward and do now. We're just looking at asset criticality and then cost of failure. And this is where I'm saying if you look on the side, all three maintenance philosophies are in there. You're going to have that quarter horsepower pump, has very limited effect on what happens at a plant. Its criticality is low. You can have 5 of them stocked, spare parts are low, but that cost of failure on it, does it really affect the plant much? No, you can change it out really quickly. So just keep that as run to failure. It doesn't mean you have to start putting extra resources towards it. If you understand and go, hey, I've got something that's a little bit more critical, and the cost of what will happen if this goes down at 2 o'clock in the day, you might see a little perturbation in production, but not a bunch. Hey, if it's not that highly critical, doesn't have that high cost to you, that's a great one to have PMs done on it. You can store those spare parts. Again, it's not really affecting you that much. When we get up to our route base, again, you can start to see asset criticality starts playing a major effect in this. And even on that level, we start talking, you have weekly routes, you have monthly routes, you have quarterly routes, semi-annual, annual. Even inside that, there's all the different classifications of where you want to fall. But that's the stuff we're starting saying, if this asset goes down, I'm going to start having an effect on my production. And that cost is going to be associated with it. And you can say, this is why I need to have these technologies, why I need to go out and buy a vibration analyzer or have ultrasound. And I got to have certified people. I got to spend to have them trained. You want to put that, because that really will be a small cost compared to if you lose that asset in the middle of production. And as we started talking about, we have our remote monitoring. That's where you start saying, that's the one. You start losing that, you're talking major loss in production. But cost to put remote monitoring in is not cheap. But you're starting to say the criticality and the cost of the failure justifies putting in a more expensive equipment. Something that's going to give me that data, 4 or 5 times a day, 3 times a day, whatever the frequency you need to actually have. And then actually, this has been the exciting part in the last really couple of years. Now starting to have guarantees on remote monitoring. If you're not told that a failure is coming, having a warranty, around it to say that asset and the parts are covered. And then the future is actually going to uptime guarantees. You start getting enough data on enough pieces of equipment to be able to say, we can guarantee that you will not have any production issues. And if you do, you're gonna have a warranty that's gonna pay you back. I mean, whose boss wouldn't love that? We're not there yet. We're getting there. But I mean, we've made huge leaps in the last couple of years. But again, if you look at this, the risk mitigation drives business value. So understanding your asset criticality is huge. That really places everything in your plant and how you go forward by understanding that. And if you don't, it really causes major problems. So I kind of talk about, what's a holistic perfect world? I mean, this is kind of, where we want to put everybody on the path to. It's, plants should be using all 3 philosophies, again, based on your criticality of your equipment. And this is starting to get the big parts. Prior to performing PM-based work, a review of the equipment's health should be performed with PDM technologies to determine if it's necessary. We're starting to talk about not having each one of these technologies and philosophies in their own silos. They have to start communicating. If you can use this to communicate, what if you could push that PM out? The PM to go change out the coupling. What if you could add another 6 months to that? What's that going to affect? That's more production time up. You're saving your man hours. But vice versa, the same thing. PDM and PM schedules should be adjusted based on a review. It's fine. It's what do you do with the data? Hey, PM was done. Do you guys document what the findings were? Do you go in and look at the parts, or are the parts just taken and scrapped? Go in and look at the coupling when you took it out. What's that insert look like? Gosh, we're not seeing any wear on it. Maybe we should adjust the frequency. Hey, if that's happening, or we are seeing more wear on it, should we just tell our predictive group, let's monitor more often so we can see what's going on, get a better basis on it? And then run to failure should be implemented on assets that don't fall into the right, criticality level. They don't warrant any additional resources. You can live with, hey, this is down. Hey, if it goes down now, hey, can we wait till 8 o'clock in the morning to fix it? You know what, we can. Then let's just do that. So kind of, talk about, is getting this holistic, but I mean, what's really the ultimate goal? I mean, Mr. Fry said it yesterday, it's reliability. Why do we want that? Reliability is the ability to keep equipment running for a longer period of time. What's that mean? That's our increased runtime, increased production. Again, in medical terms, that is increased life expectancy, increased quality of life. I mean, that's really where everybody wants to get to. So I've talked about, now we've got granular level data, we've got all these PMs. Again, it kind of already started leading into this. It's what do you do with that information? So you flag an issue. What's going to be done? It's just, again, medical. You're diabetic. You go out, you prick your finger, you get your blood results, and your blood sugar's wrong. Okay, just throw it away. Do you make a change, or you just say, whatever? It's, I always like to say, anybody ever notice, somebody in a Fitbit challenge, how many steps, and you got some guy sitting down on the couch, and he's just kind of sitting here going, shaking my hand, oh, nope, not enough steps yet. Oh, yeah. But is he really doing anything to make his life better? You go out and get your EKG, but then you come back and you don't change your diet or exercise. So it's about, we got information, but what are you going to do with it? And I'm going to tell you right now, this was a painful one for us. This is where, I'll be honest, I fell flat on my face. We had a customer, probably about 7 years ago, come in, and a new reliability engineer came into the plant, and he's like, I'm going to change how everything's done here. He came to us and said, I want to bring you guys in. I want to do predictive monitoring on everything in the plant. Well, but you did a criticality. Yep, we did a criticality asset, and we understand everything here. And yeah, he starts talking. We're looking, going, we have to embed a guy in this plant because 3 weeks every month he's going to be there collecting data. Now, this plant has 4 or 5 different buildings, but honestly, we're looking at going, whew, yeah, look at that money that's going to be rolling in on this one. We didn't challenge him, and we didn't really come back and challenge the criticality. And started looking at it, and it's 7 months in. Guess what? That reliability engineer was no longer employed at the company. A couple months later, they said, thank you, but your service is no longer needed. I started to come back to him and said, hey, well, okay, so can you tell me a little bit more why? And they basically came in and said, well, you're taking readings, you're getting readings every month in this stuff. We're not doing anything with it. They didn't get the buy-in from the maintenance guys. The maintenance guys were like, well, he may have done his criticality, but that's not our criticality, because we can run without that asset. So you write a report on it. We saw reports 4 or 5 months where we're saying, you need to change this out, you need to change this out, and it's still there every month. It's because they didn't get the plant buy-in, and they really didn't understand their criticality. You just had a reliability engineer who came in and said, I can make this world so much better, but he didn't really dive in and figure out what's really needed. So you get the information, but what are you going to do with it? Again, it gets down to that first building block, understanding your criticality of your equipment. So, kind of talked all about this, but now it's kind of getting into what else can you do? And to kind of take this forward, I'm going to kind of turn this over to Mark Hatfield, and he can kind of take us forward on what else you can do to get prepared. And I've talked about all these technologies and that, but that's just the start. There's a whole lot more we can do to get prepared. So.